Today we will be solving equations with fraction bars. So we're going to do something similar to what we did the last couple days. We're going to eliminate the fraction bar, and the way we're going to end up doing that is multiplying by the denominator. There's only one denominator here. The key is you have to multiply both sides by the same value. So if I multiply this right side or this left side by 5, I've got to also multiply the right side by 5 as well. Here the 5's cancel out. That's why we did that. And I'm left with a 4x plus 1 equals 25. So from this point, all we're doing is opposite operations to solve. You got to subtract 1 from all sides. Once we do that, we're left with a 4x equals 24. Well, we go ahead and divide by 4 on both sides, and we'll end up with our answer. So x equals 6. Let's take a look at our next problem. So the next one, we have the difference here is that we have the constant on the left-hand side, but it's no different. We're still going to multiply by a number to cancel out the denominator on the right. And so I'm going to multiply by 2, and that'll cancel out those 2's. Important thing to remember is to multiply the left side by the same value. So we're left with 14 equals 3x minus 4. And so from there, it's just a matter of undoing the operations. So we're isolating the variable by adding 4 to both sides to the 14. So we're left with 18 equals 3x. So from this point, all you have to do is divide by 3, and you got your answer. So 3 does go into 18 evenly. It goes in there 6 times. So 6, again, is our answer. We'll try another one here. We'll multiply both sides by 3. And that will again cancel out the denominator. So what we're left with is this 3 plus 2m equals 27. So from this point, we're going to subtract the 3 from all sides, leaving us with this 2m equals 24. So from this point, all you have to do is divide by 2, and we'll have our answer. So m equals 12. Now the next problem says that Stan's, Fred's, and Mark's ages are consecutive. Consecutive, this means just one after the other. Consecutive whole numbers. So for instance, their ages would be like 1, 2, and 3, or they could be like 51, 52, 53. It's just consecutive whole numbers, just numbers that are one right after the other. Well, it says the sum, so that means we're adding their ages. The sum of their ages is 144 years. Find the ages. And so we don't know Stan's age, don't know Fred's, don't know Mark's, but we know that they add together to make 144. So if I had, let's say, S plus F plus M, that would equal 144. Well, what we want to do is instead of having different unknowns, we want just one unknown. So let's do this. Let's say that Stan's age, Stan equals S. Alright, if that's the case, then Fred's age would equal S plus 1. And then Mark's age, and again we're assuming that Stan's the youngest, Fred, then Mark. And then Mark's age would be S plus 2. Because again, if let's say Stan was 51, Fred would be 52. That would be 1 more than Stan's age. Mark would be 53, which would mean that would be 2 more than Stan's age. So now we only have one unknown. We only have this one S as our unknown. So let's go ahead and rewrite our equation that we've had over here. So we have S still, plus, but in place of Fred's age, in place of F, now we're going to put S plus 1. And in place of Mark's age, we're going to use this expression here, this S plus 2. And then it's going to all add together to equal 144. So now we've got some terms we can combine together. So we're going to add up the S's. So we've got 1 S, 2 S's, and 3 S's. We've got 3 of Stan's ages here, and so that makes 3S. And then we're going to go ahead and collect the 1 and the 2 together, and that makes 3. And this now equals 144. So now we've simplified it to a two-step equation. So all you have to do from here is undo it. Subtract the 3 from all sides. You got 3s equals 141. Divide by that 3 and see how many times it goes in there. Well, I know that 3 goes into 14, goes in there 4 times. So I know s is going to equal 4, and then it goes into 14, again, 4 times with 2 left over. So 3 into 21 goes in 7 times. So Stan is 47. So that means that Fred would be 1 more than that, which would be 48. And then Mark would be 1 more than that, which would be 49. So that's how I got my answer. Now, here it says Ed's, Ted's, and Al's ages are consecutive even integers. That would mean like 2, 4, 6, or it could be like 62, 64, 66. So consecutive even integers, the sum of their ages is 72 years. So again, we'll do the same sort of thing. Let's say that E equals Ed's age, and we'll just say Ed's age equals E, and we'll say that Ted's is going to be Ed's age plus 2. You see, if Ed were 2, 2 plus 2 would be 4, and that would be Ted's age. And so let's do that once more. Al's age is going to be Ed's age, not plus 2, but plus 4, because you see how if Ed was 2, 2 plus 4 would make 6. So now we have just one unknown. So what we can do is add those up, because it says the sum of their ages is 72 years. So we got Ed's age, we got Ted's age here. I'll put parentheses around it so you can see it a little bit better. And then we have Al's age here, Ed's age plus 4. And so that all adds together to make 72 years. So now let's go ahead and combine some terms. So we can count up how many e's we have. We have 1, 2, 3 e's being added together. So that makes 3e plus, and then we have 2 plus 4 makes 6, and that all equals 72. And so from that point, what we're going to do is just opposite operations like we've done before. So subtract the 6 from all sides, subtract it from that 72. That leaves us with 3e equals, and that leaves us with a 66. And so from this point, we're ready to solve once more. So we're going to divide by 3 on both sides. And so Ed is going to end up being 22 years. So that would tell us that Ted is going to be 2 years more, so that'd be 24. And Al, he's going to be 2 years more than Ted, or 4 more years than Ed, which would be 26. So those are the numbers that add to make 72. Well, those are the types of problems you're going to see on tonight's homework. Good luck.